Amy plots the points x, -4, 2, y at -1, -5, and z at 3, -1 on the coordinate plane. She joins the 3 points to form triangle x, y, z. The first part of the question is to find the lengths of xy, yz, and xc. The second part of the question is triangle xyz an isosceles triangle. Explain. So for now, let's set aside the second part of the question and take a look at the graph. So here all 3 points were plotted and the line segments that connect them were placed. So to begin with, let's take a look at the length of x, y. So I have that the distance of x, y equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Before we begin, let's label our points. Let's assign this. So I'm going to assign x to be x1, y1, and I'm going to assign y to be my x2, y2. So my x2 value is a -1, and my x1 value is a -4. My y2 value is -5, and my y1 value is 2. I now need to simplify my expression. So looking inside the parentheses, I have a -1 minus a -4, which is going to give me 3 squared. And then if I have a -5 minus 2, I will have a -7. Three squared equals 9, and a -7 squared equals 49. 9 plus 49 equals the square root of 58. And I'm going to leave it as the square root of 58 because it is more precise than giving an approximate value. Now let's take a look at yz. Next, I'm looking for the distance between y and z. So my distance from y to z equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So now I need to assign my values. So I'm going to use y as x1, y1, and z is x2, y2. So my value for x2 is 3, and my value for x1 is a -1. My value of y2, is a -1. And my value of y1 is a -5. Now I need to simplify what's inside of my parentheses. So 3 minus a -1 gives me 4. And a -1 minus a -5 gives me 4. So I have 4 squared, square root of 4 squared plus 4 squared. 4 squared is 16. 16 plus 16 gives me the square root of 32. So here my distance of yz equals the square root of 32. Let's take a look at our final side. We will now look at our final side, which is xz. So we are looking for the distance from z to x, which equals the square root of x2 minus x1 squared plus y2 minus y1 squared equals, and now let's assign our values for x1 and x2. So I'm going to make x my x1 and y1. Sorry, it's being very funny up there. And your z, I'm going to make x2 and y2. So now let's plug those values into our equation. So my value of x2 is 3. Make that green so it stands out. And my value for x1 is a negative 4. That will be squared. I'm going to add that to my values. For x2 is a negative 1. And my value for y1 is 2. And that will be squared. So now I need to simplify what's inside of my parentheses. So here I have 3 minus a negative 4, which is 7. And I have a negative 1 minus 2 to give me a negative 3. So the square of 7 is 49, and that will be added to the square of a negative 3, which is 9. So I get the square of 58. So the length of xz equals 58 units. So now it's time to come back to the second part of the equation, or the problem. Is triangle XYZ an isosceles triangle? So remember, in order to have an isosceles triangle, at least two sides need to be the same length. So let's revisit what we found. We found that the length of XY equaled the square root of 58 units. We had that the length of YZ equals the square root of 32 units. And the length of XZ equals the square root of 58 units. So I see here that I have XZ and XY both equal 58 units. The square root of 58 units, so yes, XYZ is an isosceles triangle because the length of XY equals the length of XZ.